Hi there, my name is Shelley. Welcome to this series of lessons on linear inequalities. I'm sure you'll be glad to hear that linear inequalities rarely are used in the workplace. They are needed to monitor safe operating levels for heavy machinery and for working out the maximum possible profit in a business. Of course, we will need to establish the basics of linear inequalities before you can go and make loads of money in business using this clever maths tool. By the end of this lesson, you should be able to use a number line to represent a linear inequality, use set builder notation and interval notation to represent a linear inequality. Do you remember linear equations? In any equation, the values on the right-hand side need to balance with the values on the left-hand side of the equation. We saw this with the coin and the paper clips on the ruler, remember? Well, if we added a few more paper clips to the one side, then it will not be equal anymore. In fact, it will then be an inequality. Take this equation. 2x plus 3 equals x plus 8. This means that the value of 2x plus 3 is the same as the value of x plus 8. But if we add something to this side of the equation, let's say 5 to 2x plus 3, we get 2x plus 8 on the left-hand side of the equation. This makes the side with 5 added heavier, and so everything becomes imbalanced. This is called an inequality because the sides are no longer equal. In maths, we represent an inequality with the less than sign, or the greater than sign, or the less than or equal to sign, or the greater than or equal to sign. Remember, whatever lies on the bigger side of the arrow will be the bigger amount, and whatever lies on the smaller side of the arrow will be the smaller amount. Back to our equation, and because we've added 5, we get 2x plus 8 is greater than x plus 8. And this is a linear inequality. The value of the left-hand side is greater than the value of the right-hand side. Actually, you could also read this the other way around. The value of the right-hand side, x plus 8, is less than the value of the left-hand side, 2x plus 8. Here are some more examples of linear inequalities. X is greater than 90, or 90 is less than x. 2x minus 5 is greater than or equal to 100, or 100 is less than or equal to 2x minus 5. And 2p minus 7q plus r is less than or equal to 0. Let's have a look at different ways of representing linear inequalities. A spaza shop has at least 20 customers who buy bread every day. The owner can't buy more than 30 loaves of bread in case he can't sell them all. He would have to throw away or give away what is unsold at the end of the day. We can represent the number of loaves of bread sold daily on a number line that looks like this. We use a full dot on each number from 20 to 30 to show that the set of bread sold includes each natural number from 20 to 30. This is because the shop owner does not sell half loaves of bread. So each day he will sell at least 20 loaves of bread because he has at least 20 customers. But if he's lucky, he may sell more. So his total will be somewhere between 20 and 30 loaves a day. Now, we can also represent the number of loaves of bread in set builder notation, like this. Now, I know this may look complicated, but it's actually easy. Watch this. These brackets over here tell us the set of. The x tells us it's the set of all x. Over here we have x is an element of natural numbers, and in the middle we have our inequality. So it says B is the set of all x such that x is smaller than or equal to 30 and greater than or equal to 20, where x is an element of natural numbers. Let's look at another example. A lottery has 20 million rand to give to a lucky winner. The newspapers have estimated that winnings this week should be at least 3.5 million rand. Zakile Dlamini, a 75-year-old pensioner, is a winner of X rand. Now, can you write an inequality to represent what we know about his winnings? If the least he could have won is 3.5 million, and the total, that is the pot, is 20 million, then he must have won between 3.5 and 20 million rands. So, his winnings of X rands will lie somewhere between these two amounts. So, we can write that as an inequality. X is smaller than or equal to 20 million and greater than or equal to 3.5 million. And when we write this on a number line, it looks like this. This time, we have not used separate dots on each number. Why do you think we've used a line to join the dot on 3.5 million to the dot on 20 million? Well, the amount won could be any number in rands and cents between these two amounts. So, our x is any real number between these two amounts. Although, it would be rounded off to rands and cents. Easy, hey? We can also represent this inequality using set builder notation, like this. L is the set of all x such that x is smaller than or equal to 20 million and greater than or equal to 3.5 million, where x is an element of real numbers. For real numbers, there is a third way of representing this set. It is called interval notation. Now, the square brackets represent all possible real numbers starting and including 3.5 million and going up until 20 million, including 20 million. But always remember, we cannot use interval notation for natural numbers, only for real numbers. Now here's an interesting one. Two mountain climbers from France decide to raise money for AIDS orphans in South Africa. Once they pass the 5,000 meter mark, sponsors will pay them according to how high they climb. Mount Everest is 8,848 meters high. Write a linear inequality to represent the possible heights they will get sponsored for. Well, they will only get sponsored for more than 5,000 meters, and they can only go up to 8,848 meters, as that is the height of Mount Everest, the highest mountain in the world. So we can write our inequality. X is greater than 5,000 and less than or equal to 8,848. We can represent this on a number line like this. The open dot on 5,000 tells us that we do not include 5,000. We have to go higher than 5,000 to be paid. We then have a solid line to show us that it's anything in between, and then we have a solid dot to tell us that we can go up to and including 8,848 meters. We can show this in set builder notation like this. This reads, P is the set of all x such that x is greater than 5,000 and less than or equal to 8,848, where x is an element of real numbers. Now we can also represent it in interval notation. Here, the round brackets tell us that we do not include the 5,000, and we go up to and including the 8,848 because of our square brackets. Can we show different linear inequalities on the same number line? Yes, we can. And here's how you do it. If you are given x is smaller than or equal to 8, x is greater than -1, and x is greater than 5 for x an element of real numbers, and you are asked to find the set of possible answers to this, you should show this on a number line like this. So, what do all these lines mean? Well, this line over here means that x is greater than 5. This line tells us that x is less than or equal to 8. And this line tells us that x is greater than -1. Now this area of your graph is where all your solutions overlap. So this would be the answer. This is the set of answers that satisfy all the inequalities, and it lies between 5 and 8. It does not include 5, but it does include 8 because the dot is filled in. So we can show our solution on a number line like this. Now, how would this look in interval notation? Well, it would look like this. And in set builder notation, it would look like this. I hope you managed to get the same answers. From this episode, you need to make sure that you can use a number line to represent a linear inequality, use set builder notation and interval notation to represent a linear inequality. Here's one you can try yourselves. Show x greater than or equal to 10 and x less than 13 for x elements of a real numbers on a number line. Represent these values for x in set builder notation and in interval notation. Well, that's the end of this episode. Next time we'll be solving linear inequalities.